Here's our second lesson on heat transfer. So what we do is we get a Bunsen burner here and we heat some water up at the top of the boiling tube, and at the bottom of the boiling tube here we've got some ice which is just held down by some copper gauze. Okay, the point of this experiment is if you had a metal rod and you did this, then you were holding it here, your hand would burn because the heat would conduct down the rod. But when you do this, what you find is that you can get the water up here to be boiling away happily and still have ice on the bottom. Okay, how is that possible? Well, what it's telling us is that water is not a good conductor of heat. Water is actually an insulator. Okay, and this lesson really is about understanding how it is that all of the water, for example, in a kettle can get hot, even though the water itself is an insulator. Okay, well, so what we're doing is we're talking about how heat transfers through liquids and liquids and gases. Okay, and the key word here is this convection. And we're trying to get some sort of particle ideas into this to understand it if we're trying to get a high grade. So you might have seen these two demonstrations. This is just water in here, so this is full of water. You heat it in this corner and you just put some coloured dye in here in order to see what's happening to the water. And what you see is that the water rises up here, okay, it falls down there. That's what we call a convection current. Okay, the hot stuff rises, the cold stuff falls down. Okay, in a minute we'll talk about why that is. That's in water. It's also true in air. Okay, this is kind of an old mine shaft ventilation idea, that if you're working down a mine, you can dig a hole above it to try to get some air in, but the trouble is you want the air to be coming down this way. Okay, so what you do is you light a fire under another hole. That makes the air go up here, and that sucks in more air down there. We put some smoke in the air so you could see the way that the air was moving, but it sucks the air in here, so this person slaving away here has got some oxygen to breathe, and that again is a convection current, just like the one above. That's the principle of convection. The key thing is, why does it happen? Okay, and the idea is that when you've got particles in a gas, the particles are moving around inside a box. When you heat the gas up, those particles go faster. That will make that same air, so the same number of particles now, takes up a bigger volume because the particles are whizzing around faster. Okay, this is therefore, relatively speaking at least, high density. This is a low density. And what happens is that high density stuff tends to fall and low density stuff tends to rise. Okay, so just going through the steps here, I'll just give you the answer to this. So when the fluid is heated, the heated fluid just means liquid or a gas. This applies to either one. The particles move faster. That makes it expand. Because it expands, it becomes less dense. This causes a force of upthrust. Remember, all the way back to year 7, the idea that if you've got something immersed in a fluid, there's a force of upthrust on it, and that makes the hot fluid rise. Okay, the crucial line to get out of your head here is heat rises. Okay, that's very, very bad. Do not write heat rises. Okay, hot air rises. Okay, hot water rises.